All right, this question is really testing your ability to do electron geometries. The answer to most of this question, except for sigma and pi bonds, comes from the electron geometry. So the molecular geometry, hybridization, and bond angles, that's all a function of the electron geometry. So that's the first thing we have to figure out. Then we can go back and we can just count the number of single and double bonds or single and triple bonds or combinations thereof to get sigma and pi bonds. And we'll do that part last. Okay, so let's do the electron geometry of the first one. So I'm pointing at the nitrogen. So I want to count geometry groups. I've got 1, 2, and 3 geometry groups, including the lone pair. So 3 geometry groups is trigonal planar electron geometry. With 1 lone pair, though, the molecular geometry is bent. All right, so the next one, I've got 1, 2, 3 geometry groups from bonds and another geometry group from lone pairs. So that's 4 total. That's a tetrahedral electron geometry, but with 1 lone pair, it's trigonal pyramidal molecular geometry. All right, so the next one, the oxygen, it has 1, 2 geometry groups from bonds and 1, 2 geometry groups from lone pairs. Again, a total of 4 geometry groups. That's that's tetrahedral electron geometry. And with 2 lone pairs, I get the same as the first one. I get a bent molecular geometry. It's just a different bent than the one that we had with the nitrogen. Okay, let's do that last carbon. Look all the way over there on the left, that last carbon. I've got 1 geometry group from the single bond, and I've got another geometry group from the triple bond. Remember, double and triple bonds count the same as far as geometry groups as do single bonds. So it's a total of 2 geometry groups. So that means it's linear as the geometry there. Okay, so let's go ahead and do the hybridization and the bond angles. Remember that those things also come from the electron geometry. So for the first one, the electron geometry was trigonal planar. So the bond angles and the hybridization will work like this. The hybridization will be sp2. The next one was tetrahedral. So the hybridization is sp3. The next one was tetrahedral as well, so the hybridization is still sp3. And the final one was linear, so that one is sp. Now let's do those bond angles. So with the trigonal planar electron geometry, I get a 120-degree bond angle. With tetrahedral electron geometry, I get 109.5 degrees. So that applies for the next one as well. And for the last one, of course, it's linear, so that's 180 degrees. Okay, with sigma and pi bonds, remember that a single bond counts as a sigma bond. A double bond has 1 of each, 1 sigma, 1 pi, and a triple bond has 1 sigma and 2 pi. So it just is counting all the bonds up. So around that nitrogen, I've got a single bond, so that counts as a sigma. And I've got a double bond, so there's 1 sigma there. So that means for that one, I have a total of 2 sigma bonds and 1 pi bond. All right, for the nitrogen in the next one, I get 3 single bonds, so that's just 3 sigma bonds. For the oxygen, I have 2 single bonds, so that's 2 sigma bonds. And for the last one, the carbon, I've got a single bond and a triple bond, so that's 2 sigma bonds. And remember, there's 2 pi bonds in the triple bond, so that's a total of 2 pi bonds there for that last carbon. Okay, that's what the question wanted you to figure out. And so remember, again, it's just a test of geometry, electron geometries. Okay, thanks.